here is a positive quadrant and negative quadrant, so likely 0 would appear in this quadrant. Can you see it? On the opposite one, the same thing. In this quadrant, that is the result of the negative plus positive, so that likely we will have a 0 here. So the 0 point will be something here and here. Are we okay? And then we're looking into the detail how to find the point. And for example here, say, let me say if here we have set a point here, and this point has the coordinate, say, y and z. So that point is here. The point is here. So the point has a y and z. So that means from this point, I guess this has the distance is how much? This distance is, from here to here, y. And this point is here, so from here, the distance from here to here is z. Okay, with those numbers ready, the total stress for this case will be the superposition of the two cases. And now I'm calculating at the point with the coordinate yz. At this point with the coordinate yz, I want to calculate the generic expression for the stress. Again, we put into our formula the magnitude is sigma equal to my over I. We take out this formula, and this is m. Magnitude of the m for this case is mz. Multiply the distance from the point to the neutral axis, which is y, and divide by I. Respect to the neutral axis is z. At this point, here you can see that is positive, right? So for positive y coordinate, this point has a positive y coordinate. So this is a positive value, and make the whole thing, this whole thing must be in positive range in tension. So here we know that this is positive. Want me to repeat this again? So again, for this case, for this subsystem, the first one I calculate is to calculate the magnitude. The magnitude follow up this equation. That is the magnitude of the m. What is the magnitude of m? The magnitude of m for this one is mz. And multiply with the distance from the point to the neutral axis. Distance from the point to the neutral axis is given by y. Divide by the moment of inertia respect to the neutral axis, which is z. So now this is the magnitude. And now I'm going to assign the whether it's compression or tension. Now this point is here. And this point is in the tension range. So by assigning a sign, we have to make the whole thing, this is a sign here, where I'm going to fill it up. The whole thing must be in tension. Okay, so you look at right now, y for this point we illustrated, y has the positive value. Y is a positive coordinate. So this positive coordinate making the whole thing, try to make the whole thing be positive, be in tension. So naturally we add positive sign. Okay? Now to this point. The magnitude and m is my, and this is the distance from the point to the neutral axis. Right now the point to the neutral axis is given by z, and divide by I respect to the neutral axis, which is y. Okay, now this is a magnitude. This magnitude is at this point is in compression range. So with such a sign here, we have to make sure the whole thing is negative. And now we can justify the sign by C. Now you can say at this point Z is a negative coordinate, right? So negative with this one, if we put a plus sign here, so the whole thing will be intrinsically, will be negative already. Are we okay? So now basically let me clean this one. So this is mz y iz plus my z iy. And here we're asking this one equal to 0 to be the neutral axis. So this is the equations for neutral axis. Okay, and then we can plug in the calculations. So here, for example, the my, mz equal to 300 square 3. This is 300, and iz equal to 140.625 minus 3 inch force, and iy equal to 15.625 times 10 to the minus 3 e to the fourth power. So we plug in everything here. So 0 will be equal to mz 300 square 3 times y divided by iz 140 . So basically here in this equation, we can multiply 10,000. So this term multiply 10,000, this will be gone. This term multiply 10,000 will be gone. So basically here 0 will be equal to 300 square 3 and divided by 140.625 y plus 315.625 times z. So here is a constant, here is constant. So here is z, here is y. So here for this case, we have the coordinates like this. Then that indicate is the somehow the neutral axis should be in this orientation. Are we okay?
Dr. Cheng,
yes.
It seems to me maybe when we did the mz times y over iz, and we picked that first quadrant in the top right, could we just arbitrarily pick any quadrant?
You can pick any quadrant. And we can try this again. zy and so for example, we can pick the point here. Okay, this point has the coordinate y and z, and here. So here, this point, this is our neutral axis. This is our neutral axis. So this is the distance. Y. This is distance z. Okay, so now again, the magnitude of the stress equal to my over I. So the magnitude equal to, for this case, mz times the distance here is given by y, right? And then divided by the neutral axis about the z-axis. So in this portion, this would be upper portion is in tension. So with positive y coordinate, the whole thing is become positive already. So here is we keep that one. And for this one, the magnitude is my and divided by iy. And this one represent is the distance, which is z. And for this case, this is in tension. So that means this magnitude with the positive, the z coordinate for this case, this will be automatically positive. So that means here the total stress will be the two summation like this. So if we pick the point at this one, or compare to the point at this one, we would get the same equations for the stress. And the stress usually is a function of y and z, like this. Yes?
So wouldn't the neutral axis slope be downward sloping because one has to be positive, one has to be negative to equal 0, right? Because if they're both positive. Or
so for this one is positive, but now you look at here. For example, anyone can calculate anything for me. So you can see right now the z, the yz is a line not in our right hand rule. This one, the positive slope must be go in this way. In our traditional coordinate system, this is xy. And positive slope is always go in this orientation. But now our z is, we simply flip this coordinate system like this. You got it? Okay, so basically what I would suggest is this. With these equations, you simply label 2 points, for example, y and z. When y equal to 0, z equal to 0. And for example, when y equal to 1, then z equal to how much? Z will be equal to, you name it, will be negative something. Okay? So that means here is 1 point, and when y equal to 1, z will be equal to something here. So that will be the point. You simply connect the 2 points with a straight line. That will give you the neutral axis. Can anyone calculate this number for me? What is the value? What is the value of z when y equal to 1? Minus negative should be point something, right?
What?
I got negative 0.1924.
About this one. Okay, 0.19. So that means here is the 1 and here is minus 0.19. So that means the point is here. So now we have the 2 points. We simply use straight line to connect. That will give us the neutral axis.
Okay, can we go over why it's plus and plus again?
Yes.
This is the, I guess. Yeah, I would agree.
Like, because if you're doing mz, isn't mz negative and y positive?
How about this?
Well, I mean, looking at the
Yes.
graphs, because
Yes.
mz goes in the opposite direction.
How about this? Let me redo this one. This point, say the distance here is z. The distance here is y. Okay.
Yeah, so that's
So
a
the
negative.
coordinate should be
That's a
y
y negative z.
and negative z.
Yeah.
How about this?
Okay.
Okay, let me redo this one. So y and z right now they both are positive values, and this point located here. This point you can see is located has a negative z coordinate, so I put a negative z here, negative here. Okay, and now again the distance from here to here, this is y. The distance from here, that is z, and we do everything. Now I calculate the magnitude first. The magnitude is my over I. So m is mz times the distance from the point to here, that is y.
But wouldn't that be negative because of the orientation? Or no, sorry, no, the y is fine. But
We take the distance, okay,
yeah.
and then this divided by iz. And this point is on the tension, so this is so everything here is positive, so here, this point is in tension, so here is in tension, we get the plus here. So this one will be okay for this term? And now we go on this one. So for this one, again, the magnitude of m is my, and divided by iy. And again, what is this? The distance, this is the distance from here to here. What is the distance? And it's z.
Are you just taking the magnitude?
I take the magnitude. Distance is always magnitude.
I think it's
No.
because it's negative z and then it's under compression or it's under tension, so the negatives cancel out to a positive.
Okay.
What?
Well, no, the whole reason that it's in compression is because of its position.
Like, I can understand it a little bit more if you use I understand if they're both positive terms if you actually don't use the magnitude, because in the first term, then you have the mz is a negative quantity and then y is a positive, so making that overall negative. But then the second quantity, my is positive where z is negative, therefore both negatives cancel out, so it's a positive. Like,
Let me finish this one.
I
So
mean-
if we take the distance as a measurement, this is a distance, this is a magnitude, and the whole thing is a magnitude. However, this point is in compression. So right now here we added up the negative. So come up with, using the second illustration, this result will be the same as the previous one, because what is our previous one? Previous one is this. I simply label this one, for example, using the z.
Wait, but then that's not what you had the first time.
No, the first time is this. The first time I use the coordinate is y and z. This z intrinsically involve the magnitude as well as sign for that point.
So that means that that point is technically on the other side.
Yes, this one technically for this point, this one has
Is on-
negative value
That was that.
as a negative value here.
So what's kind of the conventional way of doing it then?
Conventional way.
I mean, like when we're doing
I think the conventional way doing this one would be this one. We simply assign any point with yz coordinate. For example, yz coordinate here would be positive, positive. For example, yz here, then that would be positive, negative. The yz here, that would be the negative, negative. And yz here would be negative, positive sign.
Dr. Cheng, if we
Yeah.
solve this equation that we just wrote here, we're going to get magnitudes, but will there still be sign when we get the equation for the line? Because
Equation of one line.
yeah, when we did this equation for the line over here, y and z were 0 equals 300 square root 3y, all that stuff. Those were points, but these are no longer points. These are
Those are
functions.
the lines, the lines. Those one, this is a function of y and z, right?
But that'll give you a different equation. than the
Yeah.
one on the left.
Um,
It's oh, just because you have a minus sign on this one and a plus sign on this one, so we're confused.
Because the two values are, the two equations are equivalent.
In the original derivations, I used the format is this format, right? And I use this format to conduct everything, and then that comes to this equation, right?
Yes, but
And in the original format, the z equal to minus lowercase z here. So